Assalamu alaikum. How are you, everyone? Hope you are all fine. Today we will continue lesson 10.4. Yesterday we talked about the prism and how to find the surface area, the lateral area, and the surface area of the prism. Today, inshallah, we will talk about the cylinder and we will learn and apply the formula for the surface area of a cylinder. Let's start. Now we have here, as you can see, two types of cylinders. The first one is the right cylinder, and the second one is the oblique cylinder. We will focus today on the right cylinder only, and we will apply the formula for the right cylinder, but just to know the oblique cylinder, the difference between the oblique cylinder and the right cylinder. Now, in the cylinder, we have, as you can see, two circles up and down. These are the bases of the cylinder, and we have also a curved surface all around. The lateral surface is the curved one, this one here, as you can see. Now, the height of the cylinder is this axis, the axis which is the altitude of the cylinder, which is the distance between the two bases. Now, how to find the lateral area and the surface area of this cylinder? Let's see how. As we said here, the height is the distance between the two circles. Now, as you can see, if we open it, we will get a rectangle and two circles. So to find the area of the cylinder, the whole cylinder, we will find the area of this rectangle, and we will also find the area of the two circles. Now, the formula of the rectangle, the length of the rectangle is the same as the circumference of the circle, which is 2 pi r, and the height here is h. So to find the lateral area here in the formula, it is the shaded one here. The lateral area is 2 pi r times the height h. 2 pi r is the circumference of the base. And to find the surface area, the whole surface area, we will apply this formula, the lateral area plus 2 pi r squared. Why 2 pi r squared? Because here we have two circles. The area of one circle is pi r squared. We have two bases, two parallel bases, so it will be 2 pi r squared. Okay, let's apply it in this example. Now, find the lateral area and the surface area of this right cylinder. Give your answer in terms of pi. Here, the radius is half of the diameter, of course. This is 16, so the radius will be 8. And the height, the distance between the two bases, is 10 inches. Step number 1, we find the lateral area. The lateral area is 2 pi r h only. Write the formula, then substitute the values. Here 2 pi times the radius, which is 8, and the height 10. The answer is 160 pi. Don't substitute pi. Number 2, the surface area is the lateral area that we found before, this one, plus the two bases areas. Here 2 pi r squared. So it is 160 pi plus 2 pi 8 squared, which is equal to 288 pi inches squared. The question asked you to write the answer in terms of pi, so don't substitute. The second example here, it is a little bit different, and it is indirect question. Find the lateral area and the surface area of a right cylinder with circumference 24 pi and a height which is equal to half of the radius. Give your answers in terms of pi. Again, so here we have the circumference, not the radius, and we don't have the height directly. We have a relation between the height and the radius. The height is equal to half of the radius. So definitely we have to find the radius from the circumference formula. Step number 1, we will write the circumference formula of the circle, C equal to 2 pi r. Then substitute the circumference, which is 2 pi r for the circumference, and the radius that we don't know, we will write it as it is here. Now divide both sides by 2 pi. So we will get the radius is equal to 12. Fine. Here the radius is equal to 12. The height, as we said, is equal to half of the radius. So in step number 2, we will find the height, which is half of the radius, equal to 6 centimeters. Now apply the two formulas. The lateral area, it is 2 pi RH. Substitute the radius, substitute the height, then we will get 144 pi centimeter squared. And apply now the surface area, which is the lateral area that we found, plus 2 pi r squared. Here it is equal finally to 432 pi. So in this lesson, you must know the formula and you will apply it directly and you'll get the answer easily. Okay. We finished the example 2. Now we have to solve check it out 2 as we used to do. Find the lateral area and surface area of a cylinder with a base area. Look here they gave us the area of the base. It is different than the previous example. There they gave you the circumference, but here they gave you the area and a height that is 2 times the radius. Again, a relation between the height and the radius. So find the radius first from the area's formula, then find the height. Okay. Apply the circumference, apply the radius here, the area. Apply the area of the circle. Here, area of the circle is equal to pi r squared. Then 49 pi equal to pi r squared, substitute, and divide by pi both sides. Put the square root for both sides, then you will get r equal to 7. Since the height is twice the radius, so the height here is 14 centimeters. Okay, apply the lateral area, which is 2 pi RH, substitute the radius, substitute the height to get 196 pi inches squared. Now substitute the surface area, which is the lateral area, plus the 2 pi r squared, which is equal to 294 pi inches squared. So substitute only the values that you get. Okay, remember, always don't round at the last, always round at the last step of the problem. Don't round many times during the steps of the solution because it will give you an answer far away from the exact answer. And keep pi as it is in the question if the question asks not to substitute it. Now, the third idea here in this lesson is to know or to explore the effect of changing of the dimensions. Now here we have a cube which is 8 centimeter length. Here the edge length of the cube is tripled. It is 8 centimeters. Now they want to triple, to multiply each length by 3. Describe the effect on the surface area. What will happen with the area? Now, in this idea, no need to find the surface area or the lateral area for this cube. I want only the effect. If we tripled the dimensions, what will happen with the area? You know that the area is something squared. So, this is the original one, dimensions, and this is the tripled one. Now, if we multiply each dimension by 3, then what will happen with the area? If the length, the width, the height are tripled, then the surface area is multiplied by 3 squared. If the dimension is multiplied by 3, then the area will be multiplied by 3 squared. Same number but squared since it is area. or it will be multiplied by 9. This is the effect on the surface area of the two cubes. Check it out for it's talking about the cylinder. Of course, the effect on the cylinder is exactly the same as the effect on the prism. Here, if the height and the diameter of the cylinder, the dimensions of this, are multiplied by half, so describe the effect on the surface area. Describe the effect on the surface area. Here also, this is the original one, original dimensions, and this is the new dimensions. This is the new height, new diameter. It is multiplied by half. Now what will happen with the area? Can you guess, please? If we multiply the dimensions, if the dimensions are halved, multiplied by half, then the surface area is multiplied by 1 over 2 squared, which is 1 over 4. This is the effect on the area. Now finally, this is the example. This is about application. When do we use the surface area in our real lives? Here, as you can see, we have two figures. A sporting goods company sells tents in two styles shown below, as you can see. Now the sides and floor of each tent are made of nylon. Now the question is, which tent requires less nylon to manufacture? Is the prism one, the triangular prism, needs more or less than the half of the cylinder? This is actually half of the cylinder, not a full cylinder. Definitely, since we are talking about the surface of both of them, of each one of them, so we have to find the surface area of the triangular prism. This we took it in the previous lesson, and also the surface area of the half cylinder. Then compare. The surface area of this is 247.4 feet square. So we need from the nylon this number, this area. And for the half of the cylinder, we need 214.8 feet square. So compare the two answers. You can see obviously that the half cylinder, the tunnel tent, is better than the prism one. So it is the tunnel tent requires this nylon, so this will be better than that. Thank you for watching, listening, focusing. If you please solve the homework after you finish the lesson. Thank you.